those extra layers. Okay, so I'm sorry this is getting cut off. Let me see if I can fix that. Does it recenter? Okay, so I'll just read it from my cheater notes right here. I think you should be able to read it from your own notes, but it says solid lithium hydroxide, and every time I see a chemical name or some useful information, I'm gonna like underline it, right? Solid lithium hydroxide is used in space vehicles to remove exhaled carbon dioxide from the living environment by forming solid lithium carbonate and liquid water. What mass of gaseous carbon dioxide can be absorbed by 1 kilogram of lithium hydroxide? Whoa, that's tough. That's like a word problem from hell. Don't worry, they're going to get harder. Okay, here's how we deal with hard word problems. First, you notice I underlined all of the names of these chemicals. And this problem is especially hard because I didn't give you any formulas. So remember, I told you, you've got to be able to go from name to formula or formula to name. Okay, so let's read it again, but this time let's put this into a chemical reaction. Okay, so it says solid lithium hydroxide. I know you can't read that. I'm sorry, it's cut off. Let me try one more time. Oh, I just made it bigger, but now you can't see what I got going on. Oh, wait a second. Kind of. You can see OLID. Anyways, you can download this file and read what it says. Okay? So let's start there. Solid lithium hydroxide. So hopefully you're able to come up with LiOH. So remember, hydroxide is OH minus, so it's a polyatomic ion, right? The whole thing is OH minus, and lithium is always +1. So lithium hydroxide, cation, anion, okay? And it says solid, so I'm gonna put that little subscript down there, and I want you to get used to putting those phases in. Sometimes we don't worry about putting the phases in if it's not that big of a deal, but when we can see with this reaction, when we have different phases, solid, liquid, and gas, you gotta put them in there, all right? So, solid lithium hydroxide is used in space vehicles to remove exhaled carbon dioxide. Okay, the lithium hydroxide is reacting with the carbon dioxide to remove it. So that means when something is getting removed, it's a reactant. When something is being formed, right, by forming, that means it's a product, okay? By forming solid lithium carbonate, okay, this one's tough. Carbonate is CO3, 2-, you knew that because you did your polyatomic ions and you made your note cards and stuff, so you're a good student. So you knew carbonate was CO3, 2-. Lithium is still, let me do that again. Lithium is still Li1+. So that means to make lithium carbonate, I need 2 lithiums for every 1 carbonate, okay? And I can write that as Li2CO3, and it said it was solid. Okay. Make sure you can do this. If you're still struggling with this, come talk to me. I'll help you make sure that you're getting formulas put together. So it says by forming solid lithium carbonate and liquid water. Okay, I know how to write liquid water. That's H2O liquid. Okay, so now it's asking me what mass, and I'm going to put a question mark next to the carbon dioxide. What mass of carbon dioxide can be absorbed by 1.00 kilograms of lithium hydroxide? So that means what I'm doing here is I'm saying if I have 1 kilogram of lithium hydroxide, how much carbon dioxide do I need to react with all of that? And maybe what you might also be thinking, did I balance this reaction? No, we got to do that. Okay, so let's balance it. Okay, so what I notice here when I start looking at the stuff that's obvious, I've got one lithium here and I've got two lithiums here. So that means I need to put a 2 here. So that means I got two lithiums, but it also means I added two hydroxides. So I'm going to have to balance the other stuff. And as we go through and look, okay, one carbon and one carbon, two lithiums and two lithiums. So we're all good there. But look, two hydrogens and two hydrogens. So that's great. And then one oxygen plus three oxygens gives me four oxygens. And then now 1, 2, and then look, 2 more, 3, 4. So it's all balanced. So I did that fast. So if you have to pause it and work this out and make sure you can get it balanced, you should definitely do that. Okay? I'm going to move forward. So now, again, what's the problem asking for? Well, the problem, first of all, we'll just say what the balanced reaction tells me. The balanced reaction tells me for every 2 moles of lithium hydroxide, I need 1 mole of CO2. Okay? That's pretty straightforward. 2 moles of lithium hydroxide reacts with 1 mole of CO2. But what's really more useful is if I have 1 kilo of lithium hydroxide, how many kilograms or grams, doesn't matter, maybe we'll keep it in kilograms since the lithium was also in kilograms, right? How many kilos of CO2 do I need to react with that? Okay, so here's what we're going to do. We're going to start with the first number that we were given. We were only given one number in this problem, 1.00 kilograms of lithium hydroxide. Okay? And I need to convert that kilograms to grams because remember in my process, I'm going to go, in this case, mass of reactant to mole of reactant. And to go from mass of reactant to mole of reactant, I have to make it grams because remember the mass on the periodic table is grams per mole. Okay, so I can say in 1 kilogram, there's 1,000 grams. That cancels the kilogram and the kilogram. And now if I look up the molar mass on the periodic table of lithium hydroxide, well, of lithium plus oxygen plus hydrogen, okay, it is 23.95 grams per mole. So I get that from the 15.99 for oxygen, 1.008 for hydrogen, and then lithium is 6.941. Okay, so 6.941 for lithium plus 15.999 for oxygen plus 1.008 for hydrogen, 23. I wrote 95, but you can see it's 23.948. 23.95 is fine. So, but now how do I use that number? Well, look, I've got grams here, so I have to have grams on the bottom, okay? Which means I'm going to say, I know it's going to look goofy to write this upside down, but this is how I have to do it. 23.95 grams of lithium in 1 mole of lithium. And I put that chemical symbol there, lithium hydroxide. I put that chemical symbol there so I know which thing I'm working with. So I just do that as an extra layer for myself. And so now I've canceled grams of lithium hydroxide, and now I've got moles of lithium hydroxide. Okay? And right in my steps, I should have a better infographic for this, but I don't. So mass of reactant goes to mole of reactant goes to mole of product. Or in this case, mole of other reactants. So sorry about that. So I could have converted it to moles of product. But in this case, I was asked, remember, you got to think about what you're asked for. I was asked for how much of this reactant do I need to react with how much of this reactant. And to do that, I have to compare moles to moles. So now I can go down and I can say 1 mole of lithium hydroxide. Oh, but wait a minute. I just wrote 1 kind of blindly because that's how I normally am used to doing this thing. But what does this tell me? This actually tells me 2 moles of lithium hydroxide react with 1 mole of CO2. Okay? So now moles of CO2 is canceled. Mole of lithium hydroxide and lithium hydroxide are canceled. Now I have mole of CO2, and it's asking me what mass of gaseous carbon dioxide can be absorbed, and it didn't tell me what units to use. So since it didn't tell me, I'm just going to actually just stick with grams. That's fine. But I'll show you how I can convert it to kilograms as well. Okay? And so from the periodic table, carbon is 12.011 plus, and look, there's 2 oxygens in CO2, so it's going to be plus 2 times 15.999. When you teach chemistry, you start to memorize all the masses on the periodic table. Okay, so 44, let's call it 44.01. And how do I use that number? Well, I have to go down, and I still have to say mole of CO2. And in this case, it's 1 mole of CO2 because it's the molar mass that I'm dealing with, right? 44.01 grams per mole. Okay? And that gives me grams of CO2. And so mole of CO2 cancels and mole of CO2 cancels. And look, I can let it ride. I can keep going. Because if I did want to make this kilograms, then it's really easy. All I have to do is one more line and just say in 1,000 grams, there's 1 kilogram. Okay? And I know what you're thinking. Well, why did I need that? Because look, they're just all going to cancel each other. Okay? And that's true. But because now we have this problem where there was 1, 2, 3, 4, 5 steps, I don't care if I'm writing like redundant information. Okay? So grams and grams cancel, and I'm left with kilogram of CO2. It's okay to be a little redundant because that's going to help me keep track of what's going on. Okay? And so now finally, when I do this calculation, I'm going to say 1.00 times 1,000 times 1 times 1 times 44.01 times 1. So I'm just going to say, to make life easier, 1,000 times 44.01 equals, and now that's going to be divide by 23.95 equals, and then now divide by 2 equals, and then now divide by 1,000 equals, and I get 0. And I want 3 sig figs, 0.919 kilograms of CO2, or that would have been the same thing as 919 grams of CO2. Since the question didn't specify what they want, either is fine. But what's useful about comparing kilograms to kilograms, that's kind of neat, right? That like roughly 1 kilogram of lithium hydroxide will absorb about 1 kilogram of CO2. It's technically 0.919, but all the same, that's kind of actually nice to see that it's about the same mass, even though we wouldn't have been able to guess that right away from the mole to mole ratio. Okay? So let's keep going. I'm going to do one more problem in this video, and it's cutting off